Today I am going to tell you how to solve a system of linear inequations, or we may say linear programming problem, graphically. So if a function is given in terms of two variables, these may be x1 or x2 or p1, p2 or p and q and xy, whatever, there must be two variables, and let z is the function of these two variables, and it is given as 10x1 plus 20x2, and we have to maximize this function, and this function is subjected to these four inequations which are called constraints in the study of linear programming problem. So the given constraints are x1 plus 3x2 is less than or equal to 18. Second, x1 plus x2 is less than or equal to 8. Third, 2x1 plus x2 less than or equal to 14. And fourth, x1 is greater than or equal to 0 and x2 is greater than or equal to 0. These two inequations or constraints are called non-negativity constraints. So we have to solve this LPP with the help of graph, which is called graphical method. So first step is to write equations for all these inequations. For all these inequations, first we write equations. So write subheading for 1, or clearly equation for 1, equation for 1, that is x1 plus 3x2 is equal to 18. And then after writing the equation for this inequation, we take x1 as 0 to find the value of x2. So x2 is equal to 18 upon 3, that is 6, and then putting x is equal to 0, we find x1 which is equal to 18. Similarly, equation for inequation 2, so write it down, equation for 2, that is x1 plus x2 is equal to 8. If x1 is equal to 0, x2 is equal to 8. If x2 is equal to 0, x1 is equal to 8. Now for 3, equation for 3, that is 2x1 plus x2 is equal to 14. So if x1 is equal to 0, x2 is equal to 14, and if x2 is equal to 0, x1 is equal to 14 upon 2, that is 7. So there is no need to write down the equations for the non-negativity constraints, because we know that if we take x-axis as the axis for x1 and y-axis as the axis for x2, so x1 is greater than or equal to 0 means on the right hand side of x2 axis, and x2 is equal to 0 means above x1 axis. So now we are going to draw the graph. So first we draw two mutually perpendicular straight lines. Taking the horizontal line as x1 axis and vertical axis as x2 axis. Generally, if the variables are given as xy, we take this as x-axis and this as y-axis. So now, taking equal graduations with a scale, though I am not using a scale, I am putting the marks with idea. So there must be some inaccuracy in, but you should practice with proper accuracy. So take equal graduations with the help of a scale. So now we see among all these equations we have found the values, different values of x1 and x2. So first we observe that which is the greatest value of x1 sorry. So here the value of x1 is 18, here is 8 and here is 7. So the maximum value is 18. So we should take the numbers on these graduations in such a way that the maximum value of x1 is covered. So if we write 1, 2, 3, 4, 5, so obviously the number of the graduations are not sufficient. And if we take 2, so 2, 4, 6, 8, 10, 12, 14, 16. Again, we are short by 2. So we better take the graduation of 3, we should say, or we may take 4, 3, 6, 9, 12, 15, 18, 21, 24. Similarly, on left hand side, negative, minus 3, minus 6, minus 9, minus 12, minus 15, minus 18, though these negative x's are useless, though it is x-axis or y-axis, because in linear programming problem we plot only the region lying in the first quadrant. That is important to us. So same graduations 3, 6, 9, 12, 15, 18 and 21. So here minus 3, minus 6, minus 9, minus 12, minus 15, minus 18. So let us start. First we plot these values of x1 and x2 which we have obtained from equation for constant number 1. So in this we have x1 is 18. So we mark 18 graduation on x1 axis, and x2 is equal to 6. So we mark 6 on x2 axis. Now we join them both. We draw a straight line passing through these 2 points properly, and this line should be drawn sufficiently long. So let it be this straight line. Though my drawing may be a little bit inaccurate, but my motive is to explain the method. So it doesn't matter if there is some sort of inaccuracy in this drawing. So this is the line for this equation. So we name this line for recognition x1 plus 3x2 is equal to 18. Now come to the second one. So second one is x1 plus x2 is equal to 8, and here the value of x1 is 8 and the value of x2 is also 8. So on the graph 8, that means close to 9, between 6 and 9 and closer to 9 there must be some point representing the number 8. Similarly, on y-axis, because x1 and x2 both are 8, so let it be this point. Furthermore, we better write the coordinate of this point of intersection of the line with the axis. So 18, 0, and here we should write 0, 6. So now we have plotted these two marks. So again we have to draw a straight line passing through these 2 points. So let it be this. So write down this equation, x1 plus x2 is equal to 8. Now come to the third one. There is x1 is equal to 7, so very close to 6, somewhere here between 6 and 9, but close to 6, because 7 is closer to 6 in comparison to 9. So let it be this, and x2 is 14, so 14 must be somewhere here close to 15. So mark it here and then join these 2 points with a line. Then name it properly. 2x1 plus x2 is equal to 14. So the point of intersection here is 0, 8, and here 8, 0, and this as 7, 0, and here 0, 14. Then we come to the most important step, that is arrow marking. Arrow marking is very important step in this process, and this is carried out with a trick which is the most important to you, and that is we put 0 in place of x1 and x2 both, and then we observe after putting x1 and x2 both are equal to 0 in an equation, the statement becomes true or it turns out to be false. So if we substitute x1 and x2 both are equal to 0, here we have in equation 0 is less than 18. We don't consider the equality sign but only the in equation. So 0 is less than 18. So that's quite clear. The 0 is less than 18 is a true statement. So if it is true statement after putting x1 and x2 both equal to 0, if the statement turns out to be true, then we arrow on the side at which origin lies. So suppose this is the in equation, and equation for this in equation is this. So we have to draw arrow marking on this line towards the origin, and origin is this side. So we put arrow marking on this, the whole line. Same thing we have to do with x1 plus x2 is equal to 8. So x1 plus x2 is equal to 8. In equation for this equation is x1 plus x2 is less than or equal to 8. So if we substitute x1 and x2 both are equal to 0, we have 0 is less than 8, which is also true. So this line divides this whole plane into two regions, one above this and other is below this. So we have to mark towards the origin, because after substituting x1 and x2 equal to 0 in the in equation, the statement becomes true. So we have to mark towards the origin again, here roughly. There is no specification for putting these arrow marking with at equal graduations or unequal, it doesn't matter. So we come to the in equation third one. So which region this in equation represents, we have to indicate on the graph. So substituting x1 and x2 again equal to 0, we have in equation 0 is less than 14, which is also true. So this line divides the whole region into two parts, this one, and this one region is towards the origin, and since substituting x1 and x2 both are equal to 0, this statement is true. So we have to mark the region towards the origin again. So arrow marking again. And as I have told you, x1 is greater than 0 means on the right hand side of x2 axis, so we have to put these marks on the towards the right hand side to show this, and x2 means the region above x1 axis. So that's all. We have marked all the straight lines with these small arrow markings. After doing so, we observe that which is that region in that graph in which all the arrows are directed in the interior of the region. That means all the arrows point towards the interior of the region. No arrow marking is towards the exterior of the region. So if we observe, there is only one region, that is this one, in which all the arrow marking are towards the interior of the region. So we shade this region first. Now the next step of this process is to observe the corner points of this visible region. So as we observe, we have one corner point is O, other one is this corner point, which is say A, and I have written A in this way, and I have put this arrow marking to indicate that this point is A, because there is very congestion and we don't write all the letters here in order to facilitate to understand this, because it must be very troublesome and very confusing. So the next corner point is this point, and say this is the point B, we name it as B, and the next corner point is this point, and this is named as C, and the last one is this D. So after indicating these corner points, or after naming these corner points, we see that the corner points must have, all the corner points must have their coordinates clearly. So simply this is 7, 0 A, the coordinates of A are clear, and the coordinates of this corner point, that is D, that is quite clear, 0, 6. But we don't know the coordinates of B and C. Two corner points are not clear. So we have to observe that of which two lines B is the point of intersection. So as we see, the B is the point of intersection of these two straight lines, that is x1 plus x2 is equal to 8 and 2x1 plus x2 is equal to 14. So we used to simplify these two equations simultaneously in order to find the coordinates of the point B. So let us start. 2x1 plus x2 is equal to 14 and x1 plus x2 is equal to 8. Subtract them. x2 negative positive cancelled out, 2x1 positive and 1x1 is negative, so 1x1 positive is left, and 14 minus 8 is 6, so value of x1 is 6 here. Now substituting x1 is equal to 6 in this equation, that means x1 plus x2 is equal to 8, we have 6 plus x2 is equal to 8, or x2 is equal to 8 minus 6, that is equal to 2. So the coordinates of B are 6, 2. 6, 2. Now come to the point C. So as we observe, C is the point of intersection of this line, which is x1 plus x2 is equal to 8, and this line which is x1 plus 3x2 is equal to 18. So now we have to solve these two equations simultaneously in order to find the coordinates of the point C. So x1 plus 3x2 is equal to 18 and x1 plus x2 is equal to 8. Subtract them. x1 positive negative cancel, 3x2 are positive, 1x2 is negative, so 2x2 positive are left, and if we subtract 8 from 18 we have 10. So x2 is equal to 5. Substituting the value of x2 in this equation, we have x1 plus 5 is equal to 8. It implies that x1 is equal to 8 minus 5 is equal to 3. So coordinates of C are 3, 5. Now only one point is left, D. No, sorry, the coordinates of D are clear, that is 0, 6. So now we have the coordinates of all these corner points of feasible region. After doing so, what is the next step? Now we write at O, that is 0, 0. With coordinates we write all these corner points one by one, and substituting these values of x and y at this corner point, we find the value of z, substituting these values of x1 and x2 in these coordinates. So here x1 is 0 and x2 is 0. So if we substitute x1 and x2 both are equal to 0 in z, we have z is equal to 0 plus 0 is equal to 0. Similarly, at the second corner point, that is A, whose coordinates are 7, 0, we find the value of z, substituting x is equal to 7 and y is equal to 0 in this function, which is to be maximized or minimized. So here z is equal to 10x1, so x1 is 7, so 10 into 7, that is 70, and plus 0, x2 is 0, and if we substitute x is equal to 0, we have 0. So 70 plus 0, that is equal to 70. So the value of z at this corner point is 70. Now next corner point is B, whose coordinates are 6, 2. 6, 2. Now we substitute x1 is equal to 6 in this equation. We have 10 into 6, 60, plus then x2 is equal to 2 in this. So 20 into 2, 40. That is 60 plus 40 is equal to 100. Then at C, the next corner point, the coordinates of C, we have found 3, 5, and find the value of z at this corner point. So z is equal to, in place of x we have to substitute x1 is equal to 3, so 10 into 3, 30, plus 5, this is the value of x2, so substituting x2 is equal to 5 here, 20 into 5, 100, 25 is 100, so we have 30 plus 100, 130. Now at last, at the corner point D, whose coordinates are 0, 6, 0, 6, and then z is equal to, substituting x1 is equal to 0 in this, we have 0, 10 into 0, and plus 6, that is the value of x2 is 6, so substituting x is equal to 6 here, 6 20s are 120. So we have 120. So after doing so, we observe that at which point z has its maximum value. If the LPP is maximizing LPP, because as you know that there are two types of LPP. One is for maximizing LPP and other is minimizing LPP. So if there is maximizing LPP, we observe the greatest value of z, and if the LPP is minimizing LPP, then we observe the smallest value of z. So here we have to observe the greatest value of Z, that is 130, and which is at C, whose coordinates are 3, 5. So we write clearly Z has its maximum value at x is equal to at C, as we have shown it. So here x1 is equal to 3, at x1 is equal to 3, and x2 is equal to 5. So Z has its maximum value when x1 is equal to 3 and x2 is equal to 5, and the maximum value of Z, is equal to 130. So this is the required solution of given LPP by graphical method.